go into that. So let's run our model really quickly. So if I wanted to run my model, I would go to Analyze, I would go to Regression, and I would go to Linear, right? You guys can see that, perfect. My dependent variable is success, so I'm gonna plunk that into here. I'm gonna plunk this into here. We will go over this in a little bit, but for right now, we just want it to be entered, right?
Which is always default, or?
It's always default, okay. Right. I don't really want to go into this because this is a very simple model, so I don't need to look at any of these. You can have confidence intervals, and I actually recommend you do click on this, so confidence intervals. R-squared change is really good for multiple regression models, so we'll go into that next week. These are some correlations which you could use. This we're going to use next week. Case-wise diagnostic is quite useful too, so it outlines any outliers that you might have. So if you do want to see some outliers, we always use a standard rule of 2. So anything above 2 standard deviations is a really significant outlier, okay? So we're going to click on that. Plots is really important because this is how we can assess some of our assumptions. So we want the residual, which is the standardized residual over here on our y. We want the standardized predicted on our x. And we want a histogram and a normal probability plot. Like, you know, Stephanie sort of mentioned, histograms are very hard to interpret, but we're just going to try it for right now. Just going to click continue. Right now, we don't need to do anything over here. But if you ever wanted to save your standardized residuals, which is what we're creating the residue plot with, you can do that over here. Okay. But right now, we're not going to do that. We don't need anything here, and we're not going to talk about this right now. Okay, so we're going to click OK. Okay, perfect. So stuff you need to include in your homework. That's also important to go through. Something, so this, yep, okay. This, the model summary, the ANOVA table, the coefficients table, not this so much, because this was extra stuff I just showed you. Not this either. The histogram, if you want to, but this one is a lot better. Okay, so the normal probability plot, and the residual plot, which is this. Okay.
Do we include one or the other, the NPP or the histogram, or do you?
Yes, you can include one or the other, but we rather see the normal probability plot.
Okay.
Yeah. So if you have to choose, do the NPP.
Okay.
Even when the problem doesn't ask for the summary table, you want the summary table.
Which summary table?
The model.
Like the model.
Yes, so whenever the question asks you run a regression and include the output, we want to see 1, 2, 3. Yes.
But if the question is just like do a scatter plot.
No, then you wouldn't include this stuff. That's right, correct. So whenever it says run a model, these are the 3 things we want.
Sorry, how do you get the summary table again? Is that just,
this is include, yes, correct. It automatically goes in, that's right.
Oh, yes.
So you don't have to do anything for this. So the model summary. Actually, you know what? I'm going to do it on here. So let's look at my slide on the right. You can look at either, but let's look at my slide on the right. Is the R value, the R square, and the adjusted R, and the standard error. The R value is the coefficient of linearity. We kind of don't care about this so much. We kind of really care about our R square. And these 2 are really important for regression. R square is telling you percent variability. Okay. So the question asks you, what's the percent variability of your model? It's the R square. The standard error, the estimate, is how your model is doing on a whole and how, you know, it would differ from other models doing the same kind of analysis. So you want your standard error, the estimate, to be low. This is really big. Again, what is big, what is small? Very relative, but this seems to be like a really big number. So, you know, this doesn't seem so great. But I will note that this adjusted R and the standard error are only useful for comparatives. So if you're doing multiple regressions, you would look at these 2 to compare models. So how would you know one model is better from the other? You would compare adjusted R and standard error. So let's do that right now.